Alright guys, let's go ahead and go over these. It looks like most of you are finished with them, so let's see how we did. We'll go kind of across and then down and do the next row. Okay, so let's go over to, it says the limit as x approaches 1 of f of x plus g of x. Eric, what did you get for your answer for this next one?
I got 1 plus doesn't exist, and 1 equals doesn't exist.
Yeah, you can't really add limits up when one does not exist, alright? So our final answer would be does not exist. And Mia, I know you were out yesterday. We can just write D and E for does not exist. Okay. All right. Let's see, Stephen. What did you get for the next one? The limit as x approaches 0 of f of x divided by g of x.
0, 2,
Perfect. Very nice. Just 0 for that one. Jake, for the next one, the limit as x approaches 0 of g of x over f of x. What did you get for the answer for that one?
2 is 0, so it does not exist.
Exactly. So answer is going to be does not exist, and the reason why as well. It makes it undefined, right?
Mm-hmm.
Okay. All right, Kristen, next one. The limit as x approaches -2 of f of x times g of x. What did you get for that one? All right, so tell me your work here. What was the in-between work? -2 times 1. Double check what we have here. As we approach -2. I think maybe I got a little bit different answer. Let me double check. I had a little bit of a different answer for that one. I did get -2 for the first one. I think for this one here, as x approaches -2, Kristen, of g of x, do you see what value it actually approaches up here on the graph? So as x approaches -2, what's the actual value for y? Yeah, does that make sense? Okay, I'm just going to go down and change that one. So your final answer would be -2 times -2, which would give you what, Kristen? 4, very good. All right, the next one was a little bit tricky. Alexa, you think you got an answer for that one?
I got 1.
Yeah, I got the same thing as well. Because all you're doing, Alexa, is basically if it's x, it would just be -1, right? And then g of x as the limit as x approaches -1 is -1 as well, right? So very nice, you do get 1 overall. Perfect. Let's see, Marissa, how about for the next one down there? What did you get as your answer? You want to kind of walk through it. So if you see the limit as x approaches 3 of f of x, right? So we're going to go up to our graph. So as we approach 3 here, what number do we seem to be approaching from the left and right? 3, good. So I'm going to go ahead and plug that in. So go back down here. I'm going to say it's going to be the square root of 3 plus 13, right? Which is really the square root of 16, which equals what overall? 4. Very good. We got it. All right, Maddie, last one. What did you get for that last one there? You want? Let's see. So the limit as x approaches 2 of g of x. So as x approaches, yeah, it'd be -3, right? And then we want to square it. So what would -3 squared equal? All right, very good. Yeah, Mia. Yep. Let's see. As we approach -1, oh, did I make a mistake? Yeah, you are right, Mia. I made a mistake. Sorry, whoever I was working that with. Mia, you are correct. That should be a positive 1, right? So that means our answer overall should be a -1. Thanks, Mia. I had that in my answer. I promise. I was persuaded by someone else. I'm sure that's never happened to you before. All right, so you can see, guys, as long as the limit exists for functions, we can do all sorts of operations with them. We can add, subtract, we can put them underneath radicals. The only issue is when we have some sort of limit that does not exist for one of the functions, so that's going to run into an issue. Or if we're dividing by 0, then our limit will not exist as well. Okay, so let's go back and kind of summarize, and I'm going to give you an example for that as well. So let's go back to your notes. All right, so we're going to do example 6 underneath properties here. So I'm going to say if the limit as x approaches some number c of f of x equals 7, okay, and the limit as x approaches that same number c of g of x equals 4, and let's see if we can kind of do some properties or operations with them. Okay, then the limit as x approaches c of 5 times f of x. What do you guys think that's going to end up equaling? So we know we have a 5 there. What can I substitute in here for f of x? If it's the limit as x approaches c. What do you guys think? So if I was just looking at the limit as x approaches c of f of x, what does that equal? What did I tell you it equals? 7, right? Yep. And you need to multiply it by the 5, right? Because you see here, Megan, how it's the limit as x approaches c. So if it's just some number, remember back in example 5 here, Megan, how if it was just some number, it was always the output was just going to be that number. So we know for down here, the limit as x approaches c of 5 is just going to still stay 5. Yeah. Oh, okay. And then the limit as x approaches c of f of x, well, we know what that is from above. It was given. So our answer would just be 35 overall. All right, let's try another one. So I'm going to say then the limit as x approaches c, let's see what I want to do in this case, the square root of f of x. What would that equal, guys? It's the square root of what? 7. Yep, you've got it. Do a couple more here. All right. Then the limit as x approaches c. Let's see. Let's do of f of x plus g of x. What is that going to end up equaling? Yeah, 4 plus 7. Or 7 plus 4, technically. What does that end up giving us? 11. All right. So you guys see how if they give you what the limits are at some point c, you can do all sorts of operations with them. Okay, you're going to have some problems like that in the homework tonight. All right, last area we're going to talk about is composite functions. See if you remember what composites are. So Roman numeral 3 is going to be composites. Does anybody remember what a composite is from like Algebra 2 or Pre-Calc? F of x of g of x? Does that kind of sound familiar? So like if you had something that asks you to find f of g of x, that means you'd take some number or some initial value, and you'd be plugging it into first what? Would it go first into g of x or f of x? G of x, good. You would get some sort of output that you would then plug into what? F of x, right? And then you'd have your final answer. So it's kind of a two-step process. Okay, so kind of a brief review of composites there. So I'm going to show you an example of this as well. So example number 7. I'm going to say f of x is going to equal 5 minus x. And g of x is going to equal x cubed. Okay. And I'm going to ask you to find the limit as x approaches 1 of g of f of x. I'll move this up a little bit too. So take a moment and see if you can think about how you would do this without my help. So take a moment so you can figure it out. So the first thing you know is you're going to want to somehow deal with what you have inside here, right? Okay, so when you look at this, you say, I really want to find, first of all, the limit as x approaches 1 of f of x. Any ideas what that answer would be? We're finding the limit as x approaches 1 of f of x. What do you think I can do? Just put 1 in for the x. So if I put 1 in, I get 5 minus 1, which is 4. Okay, so we're going to rewrite this. We're going to say now I'm finding the limit as x approaches 1 of g of 4, right? Because I found the inside of my work there. And now I just need to finish it up. So I'm going to say, okay, that means I'm going to need to find g of 4. So I'm going to plug 4 in for x here, right? And what's 4 to the third power? Yep, 64. You've got it. Okay, so again, this is just kind of another operation. We're just going to be doing composite functions. I realize, guys, one other thing I need to show you about is finding equivalent functions, because you're going to have a couple questions about that too. All right, so last thing. Sorry, this time it really is the last thing. Is going to be finding equivalent functions. So do you guys kind of remember from the video clip, you had sometimes a graph where it had a hole in it, and you could create a function that was basically exactly the same except for at one point, so you can eliminate that hole. Okay, so we're going to look at a couple of examples of that. So let's say I asked you, so last example here, example 8, I'm asking you to find the limit as x approaches 3 of x squared plus x minus 12 all over x minus 3. Okay, so when you initially look at this, can we just plug and chug like we've been doing in the past? No, right? If we put in that 3 there, it's going to make it undefined. We're going to run into some issues. So we're going to need to maybe factor a little bit and change the function so we can actually work with it. Okay, so right now, let's go ahead and maybe try factoring it and see what's going to happen here. So I'm going to say the limit as x approaches 3. And on the bottom, I can't really factor that anymore. Anybody know how the top is going to factor? I'll give you a hint. One of them is going to be x minus 3. What's the other one, Mia? Yeah, very nice. Because again, remember what two numbers multiplied at negative 12 and add to 1, a negative 3 and a positive 4. So when you look at this now that it's factored, at x equals 3, there's actually a hole in your graph. Okay, I don't know if you remember this from pre-calc, but if you have the same like term on the top and bottom that you can cross out, there's a hole at that spot. Okay, so I'm going to make a note on the side here, just to kind of remind you because that's going to become important, is right now we have a hole in the graph at x equals 3. Okay, so just kind of a side note. So basically we have a straight line, right? But we just have a hole in the graph at x equals 3. Okay, so what we're going to do is we are actually going to cross this out so that we can evaluate the function without having to worry about that hole in our graph. So now I'm going to say it's the limit as x approaches 3 of x plus 4. So now it is defined at x equals 3, and we can just use direct substitution. So if we plug 3 in, what are we going to get out, guys? Jake, what do we get out? 7. You've got it. All right, so I'm just going to make a side note here on the side. I'm going to say f of x equaling that first function that we had, the x squared plus x minus 12 all over x minus 3. And I'm going to label the next one g of x, which was just our x plus 4 once we took the whole out. They agree at every single point except what x value, guys? 3, exactly. So I think you have a couple questions like this. So this is just kind of how they want you to answer it. So agree except at x equals 3. So that kind of makes sense. You guys kind of see how that works out. I'm going to give you probably about 15-20 minutes to get started on work, and come back and talk to a couple of you guys that were out yesterday or have some questions for me, okay? So that is it for today. You're going to be working on lesson 2 homework, okay? So you can work with someone else, or you can work on your own.